And so really, uh, at a high level, we use PBS, the PBS scheduler at ALCF. If you're coming from the Polaris system, you'll see a lot of commonalities. If you're new to PBS, then there's a lot of similarity with the other schedulers, Slurm, for example. And so hopefully you'll be able to map what you do in say Slurm and into the corresponding PBS syntax. We have a lot of examples in this page here that are probably the relevant ones. Um, the first topic is running interactively. And so right now my shell sits on a compute node, or sits on a login node, sorry. And this is a shared resource with all of the users that are logging into Aurora. And so if it's more than fine to stay on the login node for lightweight tasks, but if have an application and you want to build with lots of parallel processes, dash J 52 or whatever it may be, that kind of work you would really benefit from doing it on a compute node. You'd get the compute node all to yourself. You have access to all the CPUs and the GPUs on that node. You can, very quickly, much more quickly compile codes. Once you've got those executables, you can immediately start testing it on the compute node. And so there are a lot of benefits to doing some of the initial prep work as an interactive job on a node. Um, if for example you need to debug something, on 64 nodes, you can easily submit an interactive job for 64 nodes. And so the interactive capability has a lot of benefits before, as you prepare your science campaigns. Um, and so running through quickly, the queue sub is the command to launch a job or to submit a job to the queue. Uh, dash I is very special for an interactive job. If you were just submitting a batch job, you wouldn't use dash I. Uh, a lot of options for the job attributes are they start with a lowercase dash L. So dash L select equals one. We're asking for one node of Aurora. And so again, each node has six GPUs, two CPUs. So you get access to all of that, and you'll be the only user on that node. Um, dash L wall times. This is asking for a 30-minute job. In this example, outside of this training event, you would typically submit this to the debug queue. Here in the training event, we have a special reservation set up, and I'll walk through that example shortly. Um, we need to specify the file systems that we want accessible. And so really this is good practice that if there was ever an unfortunate event that maybe the Flare file system went down, uh, or home went down, I mean, it seems unlikely that we would let jobs continue to run, but if we had let jobs continue to run for whatever reason, if your job depends on Flare file system being up, this flag prevents your job from running. This is more relevant, say, on the Polaris side of things today. But when you join all the file systems together, it'll be much more relevant there. But it's still, this is required, and so good practice. And so this is something that should just be in all of your job submissions. And then lastly, dash capital A, the project name. And so the name of the allocation by which you're going to be charging time to. Um, so for the purpose of today with this training event, uh, if I as I copy and paste the command into, why won't it let me? I think it's confused. Now it's not showing anything. There we go. Sorry about that. And so again, this is just the command that's copy and pasted from the GitHub repo. And so the project for today is the ALCF training. And then we'll be submitting this into the Aurora BootCamp queue. And so the Aurora Boot Camp queue, again, this is a reservation specifically for the workshop. And so you're you can use the debug queue if you'd like, but I would take advantage of the reservation. And again, the ALCF training is an allocation that's available for the training participants today. Um, and as you can see, executed that queue subcommand, and we're waiting for the job to start. So we're currently sitting in the queue waiting for the job to start. So that is a bit of a minor impact that to doing interactive work. But once we get that node, we can do a lot of productive things on it. Um, and then, while I wait for the job to start, once we get on that node, we can then again, set up our environment. Again, the same default environment from the login node is available on the compute nodes. And so you should be able to immediately hit the ground running with compiling software, building applications and testing them on that node. Um, and then, as happens, very often, once we, in this interactive job, once you hit the end of the wall time, in this case 30 minutes, the job will exit, and so you'll return back to the login node. Um, and then you can just keep repeating that process. Bump, 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 bump. So I was hoping this would have started by now, but
I don't see anyone on that queue, so it's very strange that it's not working. Oh,
I think the queue that shows up in QSNAP may be different. Maybe.
I see a queue that is named R1983162, which has a lot of things waiting in the queue, including a job from night.
so
I
this
think the way
part,
that I think the way the special name queue is set up is
yeah, it's just routing, so that is the, yeah. I see 23 on that number.
so this is a perfect example of why is it my job starting, and so qstat dash, qstat is a way to query the queue and properties of the queue, and so dash u username my name is Knight. And so for whatever reason, yeah, the job that I had submitted, the job ID, my username, I typed Aurora Bootcamp, but that's an alias because, trying to type this R with a long string is not so fun. And so this is the reservation that we're sitting in on a block of 512 nodes, I believe. This is the job name. If you had submitted a batch job, it would be the name of your script. With an interactive job, it's collecting commands from standard input. Number of nodes, the number of tasks, this is just a multiplier, 208 cores times the number of nodes. And so I don't pay too much attention to that. The requested time, 30 minutes. The state of the job is queue. We're currently queued. And if the job eventually runs, and hopefully it does, the queue would change to an R, and then we would see time starting to elapse. Um, so hopefully someone will get this sorted out soon. But this was working at 10 o'clock when I tested it, which is just the funniest of all things.
At
Uh,
10 o'clock, nobody else was probably queuing in that queue. If you just type QStat, you see that there are a lot of queue jobs in that queue waiting.
right. So something is blocking them from running. And so that's the issue.
Yeah.
Yeah, there's only 5 nodes being used right now in the queue in the reservation.
So the reservation is active.
Yeah, actually, I got my job started with this command, and I did it after yours.
So I did qstat dash A. And so this is showing contents for everything that's queued in the system. Yeah, it's curious.
Yeah, it looks like the routing. So there's two routing destinations for the queue. It looks like the one of the routing destinations only has 6 nodes assigned to it. So
Okay.
yeah, we'll work to get that fixed.
Yeah,
Chris, this is Silvio. Do you want me to ask the scheduling folks to take a look?
please.
I'll do.
Yeah, I was trying to connect to Herita, yes, because that should not happen.
Yeah, I'll do.
But you
Alright.
can use the other, I guess, the actual queue name for now.
Yeah, well, so I controlled C my queue sub submission, and so that's why it's asking me if I want to terminate. Yes, I want to terminate. What was the suggestion, Ozzy?
And instead of the using the Aurora bootcamp, just use the R198312316
Chris, for now, you may use the debug queue.
That's what I was thinking. It's just
Yeah, I was gonna say do that. Use the debug queue, or one of the other queues.
Yeah, it seems that the limit is 5 running, so it's doing what it was set up to be done. So maybe it has to be changed, the number of jobs to be running by. Right now, it's doing what it's supposed to be doing, maybe.
that's unfortunate. All right, so I apologize. I'm bouncing back and forth between these two shells, but I ran qstat my name in a different shell after I submitted the job a second time, and now I see that I have a job in the debug queue, and now it's in the R state. And so there's no time elapsed that it's going through the process of starting that job. And so then when your interactive job starts, you get a message that the job ID, is ready. And then the command prompt now shows the node that I'm sitting on. So this is a compute node, not the login node. Uh, and so, a very simple thing you can do is if folks that are familiar with NVIDIA GPUs, the NVIDIA-SMI tool, there's a similar one that we have here. And so, just as a very quick and easy thing to do, you can load XPU SMI module and then run the discovery command with that. And then, the formatting is a little off, but you can see, aha, I'm sitting on a node with a bunch of Intel GPUs. So that's just, if anything seems off, you can check to make sure that the GPUs are there. And if for some weird example you didn't see them, I would check, are you actually on a compute node? Maybe your interactive job died and you're sitting on the login node unexpectedly. And so I'm gonna stay on this node for the remainder. And whereas a lot of these examples submit the jobs as batch jobs. And so one of the first things we can do, and again, if you're not familiar with PBS, this is just a simple example where all of the command line options I had typed on for QSub, we can put them as at the top of a preamble inside of a job script. And so again, we have -L, select for the number of nodes, the wall time that we want, the queue, the file systems. Here I had, just have home, but really I should put Flare if I'm working on my project directory. -A for the project name. And then these examples, they place the standard output and the standard error into a logs directory. That's a user choice. You're free to put these logs wherever you'd want. The default would be the directory where you submitted the job. And really all of this simple example is doing is we set a variable equal to 6, and we're going to launch that 6 processes on the node, and all they do is echo hello world. So I am sitting in my home directory right now because as when that interactive job started, and so I'll go down to the project directory. And I have my directory that's in there. And go into the ALCF beginner's guide, into the Aurora directory, and then the examples. And so maybe it's a little hard to see in the shell, but if from Aurora down into examples, you can see these are here. Um, and then if you're submitting this as a batch job, you would just run the command q sub and then the name of the script. Um, so I will submit that as a batch job on this side. And so submitting this simple example 00 hello world.sh, which just looks like this here, q sub dash a, the name of the project that we're charging hours against. I put it dash q for the workshop reservation and then the script. And so putting dash a and dash q here on the command line overwrites whatever's in the script. And so if you went inside the script and you changed it appropriately, you could just do q sub the script. If you leave the script as is, you can make modifications on the command line. So that's a pretty convenient way to do things. And if you submit it, it returns the job ID. And so now I have this job sitting in the queue running. Probably that will sit there and wait. If I do qstat-u my username, I can see that I have my interactive job that's currently running in the debug queue, and I have this job, a batch job that's waiting to run in the reservation that we have. Uh, I'm not going to wait to see if that actually launches or not. And so in my shell that has the interactive node, I can run this directly. So the script is not executable. And so actually that's a good example, good thing to walk through. And so, but PBS on most systems, they wants the script to have that executable bit set. I've found on Aurora that that's not necessary. But still, I think it would be good practice just to make sure that your job scripts are executable. And so now I see that helpful green font that telling me that the 00 hello world.sh is an executable script. And then if I run it, because again, I'm on the compute node, I have access to these resources, and so I can just launch scripts directly. And so this script here, which is running an MPI command to echo hello world 6 times, I can see each process, prints that statement as expected. And then when my batch job finishes, the corresponding standard output in the standard error will show up in the logs directory that's here. And I'll check, is that still waiting? Yeah, that's still waiting. And so again, it's unfortunate if others are seeing jobs not start as well, but everything is I'm literally copying and pasting. And so hopefully that doesn't negatively impact people going through this. Uh, I've done qstat-u, the username, a number of times. And so that is one of those, helpful tools to try to understand what's happening. And, when asking yourself, why hasn't my job started? That's one way to probe the queue. And so usually what you would see is there's a bunch of jobs that are queued and running, and it's just your job is waiting in the queue for resources to become idle. Um, in other cases like this, there's an issue that the reservation is not set up as we expected, and so that would prompt sending in a ticket to support and discussing it with us so we can troubleshoot what the issue may be. Maybe you've submitted your batch job and you realize you've made a mistake and you want to change something. Uh, PBS grabs a copy of your submit script and it saves it somewhere. And so if you submit a job and you make changes to that batch script, those changes won't get reflected in the job, unfortunately. And so if it's a case where you've submitted it and a second later you realize that you want to delete it or for whatever reason, you can run the qdel command on that job. And so actually, if I check, is my job still queued? Yeah, my job's still queued. And so I can just do qdel and then this string here, the job ID, to delete it. And if I qstat again, I can see only my interactive job, it remains. And so You can put jobs on hold, and you can do other things with your jobs as well. And we have some of the commands that you're likely to use in this table here. And so interact, submitting jobs to the queue, probing the status of jobs that are in the queue, holding your job. Maybe you need to modify an input file, or maybe you realize uh, a dependency job, hasn't, completed yet. And so, you want your job to hold. When it's ready to run, you can release it. You can get a lot of detailed information on the nodes of the system, and also the job history of the system. QStat-X is very good to understand what happened to a job afterwards. Uh, and then queue sub options. And so things like specifying the node count, the wall clock time. Um,
Could you remind us which page you're reading from or show your screen?
I'm on the scheduler page.
Okay.
So this is, I think, near the bottom. Yeah. Um, so I think one thing that would be important is folks who have dependencies. Um, where's it at? It's not jumping out at me. Oh, okay, depend. So this would be a good option to look into if your particular workflow, you want a string of jobs to run one after the other, or to have some more complex dependencies. And so this is maybe a good one for folks to take a look at if you have such a workflow. Um, And then inside of your job, there are a handful of environment variables that get created from PBS. I would say by far the most important one is PBS node file. And so this is a text file that lists all of the nodes that have been allocated to your job. And so if I go to the interactive shell that's on the compute node, and I want to look at what is that variable, it'll give me a nice long path. So the path and the name of the file is not so important. But if I look at the contents of that file, I can see that my job, which again, I only asked for a single node, I'm currently, there's one line of output in this file, and it's, giving the node ID. If you asked for a 10 node job, there'd be 10 lines with the 10 unique nodes. And so depending on your particular workflow, if you wanted to target different applications for different sets of nodes, this by far is one of the most important files that you'll want to access and interact with. And then again, if you're doing job arrays, there's corresponding variables as well there to help.